Hello everyone. So let us continue our discussion on how we designate a chiral center with the RS nomenclature. So basically, in today's lecture, we will look into the designation of configuration of the stereo center. Okay, or we can say stereo center or chiral center. Stereo center is a more general term. Chiral center would be more apt word to say because it is kind of related to chiral molecules. So we are going to look into the real example. So previously, just a recap, first thing that we do before we designate a molecule as R and S is to identify the chiral center. Okay, the next step would be on the basis of atomic number, we will arrange the four groups into the first priority, second priority, third priority, and the fourth priority groups. Okay, once we do that, the next step would be okay to check the sense of direction when we move from 1 to 2 to third priority group. Okay, so before checking the sense of direction from one priority to second priority to third priority group, the important thing we have to check is that our fourth priority group is behind the plane, behind the writing plane. Important thing before we decide the RS nomenclature is that our fourth priority group should be behind the plane. So once we make sure that our fourth priority group is behind the plane, then when we check the sense of direction from one first priority group to second priority to third priority, and if suppose that sense of direction is clockwise, okay, suppose the sense of direction that we are feeling while moving from 1 to 2 to 3 is clockwise, we will designate that particular chiral center with a configuration R. Okay. Similarly, when if we move from 1 to 2 to 3 and we find that our sense of direction is anti-clockwise, if that is the case, then we know for sure that the configuration is nothing but the S. Okay, so this is the basic thing that you have to remember before uh, designating the configuration of the chiral molecules as R and S. Okay, so let's go back to our example that we actually started with, and that is glyceraldehyde. So let me draw the Fisher projection for you. So one of the Fisher projection that we drew was this one. OH, HOH, okay, and then we drew the mirror image. Okay, mirror image is nothing but you have CHO and OH would be here in the mirror image, and then you have a hydrogen here, then CH2 OH here. Perfectly fine. Now we have to assign the configuration. So before assigning the configuration, our first job would be to find out the priorities. Now priorities are decided on the basis of atomic number. Okay, so let us see first where this chiral, so the chiral center here is this one. Let me mark that for you. So this is the chiral center because this particular point is attached to four different groups here. So this is the chiral center. So first job before assigning the uh, R and S configuration is to identify the chiral center. Once we identify the chiral center, then we see which all atom is these chiral center attached to. So if you look carefully, one of the atom that is attached is hydrogen, another atom that is attached is OH, and another at O, right? Atom I'm talking about. So this chiral center is directly attached to oxygen. This chiral center is attached to hydrogen. This chiral center in the upward direction is attached to a carbon. Okay, and this downward direction is attached again to a carbon. Okay. Now, so two of the atoms to which this chiral center is directly attached is carbon. Okay. So we will come back to it. So now we have hydrogen, we have a set of carbon, and we have a oxygen. So we know according to atomic number, oxygen is having a higher atomic number. So obviously we know that the first priority will always come for the hydrogen. So let me denote it with another color. Okay, so first priority would be given to oxygen, this particular group. Okay, because it is the first atom that is attached is oxygen, and oxygen is having higher priority than either carbon or hydrogen. So first priority will go to this particular atom. Now, obviously, we know that carbonic, if we compare carbon and hydrogen, hydrogen will have the lowest atomic number. So obviously, hydrogen will be getting the lowest priority. So let me denote it with another color. So our lowest priority group, that is the fourth group, I'm attaching by another color called 4. Okay, so let me come back to the color now. So if we look, we have to now compare these two groups. Okay, let me write it separately and show you how we decide the priority. So one of the group that is attached is an aldehyde, that is CHO. So if you draw an expanded structure, it would be something like this, right? This you are knowing that. Another group is CH2OH. So this is nothing but your carbon attached to two hydrogens and a OH group. Okay, so whenever you find that the chiral center is attached to the same atom, then the priority is decided on the basis of the next atom attached. Okay, so carbon, in both this case it is carbon, so we'll move to the next atom. So let us first look into the CH2OH. Next atom is two hydrogens and one oxygen. Okay, so here if we look, we have one hydrogen and one doubly bonded oxygen. So we cannot clearly know whether this is having a higher priority or this is having a higher priority. To understand that, the CIP rules, that is Kahn, Ingold, and Prolog rules, which I introduced to you previously about the name, okay, it says that we can consider this double bond to be like this carbon, there is a double, like this carbon is attached to oxygen 2 times because there are 2 bonds here. So we can imagine that this carbon is attached to oxygen 2 times. Okay, so how do we show it actually? So we show this bond like this. So according to which I'm saying whenever there's a double bond, so that means this CO is C is attached to oxygen 2 times. So that means one of this bond is here and another bond I can draw something like this. Okay. So what I have done is I've split this bond into 2 times. So basically double bond means there are 2 single CO bonds. Okay. Similarly, with respect to oxygen, if we compare, it is like attached to carbon 2 times. Okay, so one time is here, another time I'll show something like this. Okay, so let me show this with a different color, then probably you will not confuse it. Okay, let me use this color. So I'm saying one is your usual bond, and another thing is an imaginary bond that you're considering here. Okay, so basically this double bond means you are considering carbon to be bonded to oxygen 2 times. One is this one and another is this one. And this, with respect to oxygen, oxygen is also doubly bonded to carbon. So oxygen is also kind of bonded to carbon 2 times. So that I can show here. One oxygen here, another carbon virtual one. Okay, so now this particular extra oxygen that I drew here and the extra carbon that I drew here, I usually show them in parentheses. Okay, I usually show them in parentheses, and these atoms that I showed in parentheses, this is called as nothing but phantom atoms. This is called as phantom atom. So it is like a ghost. atoms. So it is not a kind of real thing, but it's an imaginary thing that is used to assign the configuration. Okay. So now if we look at this particular molecule, so here I have missed one hydrogen here. Okay, there is a hydrogen here. Okay. So now if we look into here, so this CH2OH is attached to 2 hydrogen and 1 oxygen atom. This carbon, that is the CHO carbon, after we write the phantom atoms, if we look into, it is attached to 2 oxygen and 1 hydrogen. 2 oxygen and 1 hydrogen. So now it is pretty easy. So obviously there are 2 oxygen atom here and this carbon is attached to only 1 oxygen atom. So automatically this particular group is going to get the, that is CHO group is going to get the higher priority than the CH2OH group. So that is why in this particular case, the second priority will go to the CHO group and the third priority will go to the CH2OH group. Okay, so this is pretty fine now. Now let us check the sense of direction. So next step is the sense of direction. When we move from 1 to 2 to 3, what is the sense of direction that is coming? So let us see. So when we move from 1, so sorry, this is not the direction in which we are moving. So we have to move in the direction of 1 to 2 and then to 3. Okay, so if we check the direction of 1 to 2 to 3, it is coming out to be, so 1 to 2 to 3. If we check the sense of direction, it is coming out to be anti-clockwise. The sense of direction is anti-clockwise. Okay, so if it is anti-clockwise, we know from the above discussion, it should be S. Okay, now we forgot one thing, that before checking the sense of direction, we have to make sure our fourth group is behind the plane, writing plane. So if we know about the Fisher projection, I told you before, the vertical bonds are the bonds that are behind the plane, while the horizontal bonds, they are the ones that are above the plane. So our fourth group right now is above the plane. So that means this sense of direction that I have chosen will give me a wrong configuration. Okay, so whenever in the Fisher projection group, your fourth priority group is on the horizontal bond, if you check the configuration and find out to be anti-clockwise, you can easily correct it by saying that this configuration is R, because, why? Because your fourth priority group, that is your hydrogen, is above the plane, is above the plane, is above the plane. Therefore, when you check initially the sense of direction, it appears to be anti-clockwise, so it should be S, but it's a wrong configuration because your fourth priority group is on the horizontal bond, which is above the plane. So therefore, this particular glyceraldehyde is nothing but your R glyceraldehyde. This glyceraldehyde is nothing but your R glyceraldehyde. This is your R-glyceraldehyde. Now, the mirror image obviously should be S-glyceraldehyde. Let us confirm that. So our first priority would be this oxygen, obviously. Second priority would be this group, which we already just now see how we did that. So second, and this is the third. Okay, let us fourth priority group, we will use another color. Let us denote it by fourth. Now, let us check the sense of direction. So when we check the sense of direction, we move from 1 to 2 to 3. When we move, okay, what is the sense of direction coming out to be? Clockwise. So when we move from 1 to 2 to 3, okay, the sense of direction that is coming is clockwise. Sense of direction is clockwise. So we expect the configuration to be R. But this configuration is wrong. Why? Because your fourth priority group is on the horizontal bond, on the horizontal bond, horizontal bond of Fisher projection. So I'm just writing FP, Fisher projection formula. So that implies our configuration for this is S. Okay. So this particular way, if you write your glyceraldehyde, then this means it is your S glyceraldehyde. S glyceraldehyde. Okay, so it is pretty simple. Once you arrange the priorities of the group, it is pretty easy to find out the configuration of a molecule. Okay, now let us look into another example. So let me rub this out for you. So let me rub these groups. Okay, I'll use the same Fisher projection. Okay, let me remove this sense of direction. This one also. So this one, this one, this one, and this one. Okay, perfectly fine. Now, let me use our usual black color and this here. Now, let me give you another example, another molecule. Basically, suppose I have a propanoic acid. Okay, let us consider example of propanoic acid. So this is propanoic acid 1, 2, and 3. So as I told you, usually Fisher projection, whenever Fisher wrote the Fisher projection formula, he kept the carbon chain on the vertical bond. So when we do that, propanoic acid means here there is a CH2 group. So right now, if CH2 is there, then it won't be a chiral center. So what I'm going to do is, one of them is hydrogen, another is an isotope of hydrogen, that is deuterium. Okay. So if I consider the mirror image, it would be D here and H here. Now it is chiral, right? Because every atom that is attached to this particular chiral center of carbon is different. This is D, this is H, and these are different functional groups. Now let us see how we are going to arrange the priorities. So if we look in here, the first priority, how we will decide. Obviously, this is a deuterium is an isotope of hydrogen, so obviously it won't be considered first. So first would be carbon. Carbon will have a higher atomic number than either of these isotopes of hydrogen. So obviously, the first priority will be decided on the basis of these carbon group. Okay, so one of the group is CH3. So that means basically a carbon attached to 3 hydrogens. Okay, another group is again a carbon attached to carboxylic acid. Okay, so as we did here in the case of CHO, we will consider this to be equivalent to so we have an OH here. Okay, now this carbon can be assumed to be bonded to oxygen 2 times. So one is our usual bond. Okay, another is your a fake bond, which we are hypothetically considering attached to oxygen, which we will show with a parenthesis. Now, in a similar fashion, this oxygen can also be considered to be bonded to carbon 2 times. So one is the usual bond, another is a hypothetical bond, which I show something like this and attached to carbon. Okay, now let us see. So this, if we don't even have to draw these phantom structure, we can decide here itself which will be getting the higher priority, because here it is all hydrogen attached to, here we have oxygen attached, so automatically this will get the higher priority. But just to make you understand, I showed how to draw this phantom atom. So pretty easy to say. Obviously, carbon, this carboxylic acid functional group is going to get the higher priority. So the first priority would be given to the carboxylic group, because this carboxylic group is attached to 3 oxygen atom. Okay, so obviously this would be getting the high priority. However, this carbon atom is attached to 3 hydrogens, which is having lower atomic number. So this would be getting the second priority. Now, this hydrogen is having an atomic number of 1. This is deuterium, which is again an isotope of hydrogen, again having the same atomic number. So when you have atoms to be decided which have the same atomic number, okay, then the next thing says that you can decide it now on the basis of atomic mass. So we can decide on the basis of atomic mass only if the atomic number fails to explain the priority. So in this case, hydrogen and deuterium both have same atomic number because they are isotopes, but they have different atomic masses. And we know deuterium has a higher atomic mass than hydrogen. So therefore, the third priority would be going to deuterium, and then the fourth priority will automatically go to the hydrogen atom. Okay, so I hope you understood what I am saying. So accordingly, if we prioritize here, this would be first, this would be second, this would be third, okay, and this would be our fourth priority group. Now let us check the sense of direction. So when we move from 1 to 2 to 3 in this case, it is a anti-clockwise direction. So we expect it to be S, but since we have our fourth priority group on the horizontal bond, which is above the plane, the configuration would be R. Similarly here, it would be when we move from 1 to 2 to 3, it appears to have a sense of direction of clockwise direction. So we expect it to be R. But since our fourth priority group is on the horizontal bond, which is above the plane, writing plane, therefore, the actual configuration is the S. So here the actual configuration is R, and here the actual configuration is S. Okay, so this is pretty simple to understand. Let's do one more example in this video. Okay, and with this, I hope you will be pretty much sure how to do the priorities and therefore assign the RS configuration. So let us take an hypothetical example. So I'll just give you one example, CH3. We have CH2 Cl, CH2 Br, okay, and this is CH2 OH. Okay, now this is again a Fisher projection formula. Now let us arrange the priorities. So here, if we look into the priorities, this carbon is attached to 3 hydrogen. Rest of them is attached to 2 hydrogen and 1 halogen atom. Okay, here it is not halogen, it is attached to O. Okay, so now how to decide the priority? It's pretty simple. Now you might have easily understood. So in all this case, the chiral center is attached to carbon, so we cannot decide the priority. So we have to go to the next atom. So next atom is, here it is all hydrogen. So obviously this will be getting our fourth priority. So let me fix that priority first. Fourth priority here. Now let me arrange the find out the first priority group. Now all these groups have similar kind of atoms attached. So it is 2 hydrogen here, but a Cl here, 2 hydrogen here, and 1 Br. So, and here 2 hydrogen and 1 O. So we have to decide on the basis of these atoms, that is oxygen, Br, and Cl. So obviously, Br would be higher atomic number. So this would be getting our first priority. The next higher atomic number is your chlorine. The third higher atomic number is oxygen. So this will be, this particular group would be getting the third priority. Okay. Now we will see the sense of movement from 1 to 2 to 3. So when we check the sense of direction from moving from first priority to second priority to third priority, okay, first to second to third priority, it is a clockwise direction. So when we move from 1 to 2 to 3, it is what? Clockwise. So it is a clockwise direction. Okay, so that means what the configuration here is R. And an important thing to notice now, fourth group is on the vertical bond, and vertical bonds we know are the bond, the fish in one Fisher projection, the vertical bonds are behind the plane. So our condition is also satisfied that fourth group is behind the plane. So therefore, the configuration of this particular chiral molecule is nothing but R itself. Okay, because here the fourth priority group is behind the plane. So I hope you understood now that how we give priorities to various group and how we check the sense of direction when we move from first priority to second priority to third priority group. If it is clockwise, we'll see it to be R. If it is anti-clockwise, we'll see it to be S. But make sure your fourth priority group is behind the writing plane. If that is not the case, then our priority would be opposite of what we actually found. Okay, so I hope you understood this, and we will take up more example in our live session. So have a nice day. Thank you.